Differentiation. This theory primarily depends on the idea of limit and continuity of a function. Let's consider a function y equal to f of x. Here we say this x is an independent variable and y is a dependent variable dependent on the variable x. So now when we say differentiating, that means we are trying to find out the derivative of that particular function, which is nothing but rate of change in that function, which involves a very small change in the dependent variable with respect to a small change in the independent variable. So we can say the differentiation is the process of finding the derivative of a continuous function. It is defined as the limiting value of the ratio of the change, that is the increment, in the function corresponding to a small change in the independent variable as the later tends to 0. So consider y equal to f of x to be a function. If we consider a small increment h in that x, say delta x, h and delta x are one and the same, and the corresponding increment in f of x will be f of x plus h minus f of x, which we call it as delta y. That means the derivative of f of x is defined as change in y divided by change in x when this h tends to 0. H means here it is delta x. Okay. Now this can be further modified as limit h tends to 0, f of x plus h minus f of x, because that is your delta y, divided by x plus h minus x. So in the denominator, this x and x gets cancelled and you will be left with the limit h tends to 0, f of x plus h minus f of x divided by h. So this derivative can also be written as f dash of x or f of x or dy by dx or d by dx of f of y, or we can call it as y prime or y suffix 1, means first order derivative. The derivative of f of x is also known as differential coefficient of f of x with respect to x. In our subsequent video, we'll see what are the different rules applicable in differentiation.